We are now starting the paper of mechanics for the year 2018. Mechanics paper 4 M1 9709 oblique 42 May June 2018. The total timings for this paper is 1 hour 15 minutes and the total marks are 50. The instructions are given here. So you have to give the answers to the three significant figures, or if the angles are used, then you have to give the answer up till one decimal place. And the value of G should be taken is equal to 10 meters per second square. Question number 1. A man has a mass 80 kg. He runs along a straight horizontal road at a constant resistance force of magnitude P Newton. The total work done by the man in the increasing his speed from 4 meters per second to 5.5 meters per second while running a distance of 60 meters is 1200 joules. Find the value of P. Since the man is running on a horizontal road of mass 60 kg, the speed initial is 4 meters per second and the final is 5.5 meters per second. With the work done by the driving force is 1200 joules, and you are going to find out the P Newton force for that part there. So this is the driving force and this is the resistive force. This is the normal reaction R and that is the weight of that object. But because the motion is horizontal, so it means the equation we are going to use work done by driving force minus work done by resistive force is equal to change in kinetic energy of the system here. There is no role of the potential energy in this part because it is horizontal motion here. And we know that the driving force and the work done by the driving force is 1200 minus the resistive force is P into 60, that is the distance moved by that man, is equal to half mass is there 80, V there is 5.5 square minus 4 square. And from this you can calculate that 60p is equal to 1200 minus 40 into 5.5 square minus 4 square. And p value will be equal to 1200 minus 40 into 5.5 square minus 4 square all divided by 60 there. And that is the value of P we are going to get because P Newton force is there. So it should be equal to 10.5. So P there is equal to 10.5. This is the resisting force of that particle of the man with the resisting force equal to P value, which is equal to 10.5 there. Now we are starting question number 2 now. A train of mass 240,000 kg travels up the slope at inclined at angle of 4 degree to the horizontal. There is a constant resisting force of magnitude 18,000 Newton is acting on the train. At the instant when the speed of the train is 15 meters per second, it is decelerating at zero point 0.2 meters per second. Find the power of the engine of the train there. So, in this question, the train is having a mass of 240,000 kg, is moving up the inclined plane, and the resistance to that motion is 18,000 Newton with a deceleration of zero point 0.2 meters per second square. So, we are going to find out the power. First, this is the normal reaction R to that. This is mg cos of 4 degree minus this one is mg sine of 4 degree, and this is the driving force of that particle here. Since we know that the power is basically equal to driving force into velocity, and we have to calculate the driving force for this. So we know from this equation that the driving force minus resistive force is equal to NA. But the driving force is unknown. Minus resistive force is 1 is 80,000 plus mg sine of 4 degree is equal to mass of that one is 240,000 into acceleration is minus zero point 0.2 because it is decelerating, so acceleration will be taken as minus sign with that part there. So the driving force will become equal to 18,000 plus mg sine of 4 degree plus 240,000 into minus zero point 0.2. So that driving force will become equal to 18,000 m is there 240,000 g there is 10 into sine of 4 degree minus 240,000 into 1. That value is equal to this value is equal to 137415.5. So power is equal to driving force into velocity. So 137415.5 into the speed there is 15. So that thing is equal to 2061 watts. Or if you have to convert it to the three single figures, 216,1000 watts. This should be equal to 2061 kilowatt. So that is the power being generated by that train there when it is decelerating which is minus 0.2 meters per second square. Now question number 3. Three coplanar forces shown in the diagram have the magnitude 3 Newton, 2 Newton and P Newton. Given that the three forces are in equilibrium, find the value of theta and P there. These are the three forces on the plane 3 Newton, 2 Newton and P Newton, making this angle theta 60 and P Newton is making an angle of 90 degree with the base of that. Since the particles are in equilibrium, so we can write on that all horizontal forces. So we are going to solve this component into this part. It should be equal to 2 sin theta, and this component will be equal to 2 cos theta. This component, according to the direction, it should be equal to 3 sine of 60, and this component is equal to 3 cos of 60. Now, Fx is the horizontal forces, so that is equal to 2 cos theta, it is rightward, minus 3 cos of 60, it is leftward to that. So that value is equal to 2 cos theta minus 3 cos 60 is 1 by 2, and that thing is equal to 0. So this makes 2 cos of theta is equal to 3 by 2. Cos of theta is equal to 3 by 4. Now theta is equal to cos inverse of 3 over 4. And that value is equal to 41.4. So this is the value of theta there. And now you are going to solve this vertical components. Fy, that is equal to 2 sine theta, that is upward, plus 3 sine of 60 degree, that is upward, minus p, it is downward to that. And that value is equal to 0. Our p value is equal to 2 sine theta plus 3 sine of 60. 2 sine of theta value is 41.4 plus 3 sine of 60 is 3 over 2. And that value is equal to the value of p there, which is equivalent to 3.92. Because already Newton is mentioned here, so only value of numerical value of p is going to be used. So that is 3.92 and theta degree, so only theta will be equal to 41.4. So this is the question answer of this part 3. where you are going to find out the angle P and the value of angle there, theta. Now starting question number 4. A particle P moves in a straight line ABCD with a constant acceleration. The distance AB and BC are 100 meter and 148 meter respectively. The particle takes 4 seconds to travel from A to B and also takes 4 seconds to travel from B to C. Show that the acceleration of the particle P is 3 meters per second square and find the speed of P at A there. Since they are moving on a straight line ABCD, where AB is 100 meter and takes 4 seconds here, BC is 148 meter and it takes 4 seconds here. The initial speed at A is unknown, which we have taken it as equal to u meters per second, and we are going to find out the acceleration of that particle here. Keep one thing in your mind that when the particle is moving on a straight line and it passes from points from that line with a constant acceleration, then you always have to use this reference point A there, the starting point of this motion there. So let's say we are going to find out AB with a distance s is equal to ut plus half at square. So s is basically equal to 100, u is unknown, time is 4, plus half, a is unknown, and time is 4 square there. So this will become 100 is equal to 4u plus 4 for the 16 over 2, 8 a there. 4 is common there, so it should be equal to 25 is equal to u plus 2a. Let's say it is equation number 1. Now for the distance from B to C, we have to take again the point A because it is the reference point of this whenever it moves on a straight line. So now you will use AC there. So AC is basically equal to AB plus BC. So it is 100 plus 148. So that is equal to 248. U is at A is unknown. And the time there is 4 seconds plus 4 seconds is 8 seconds plus half into a square. So this will become 248 is equal to 8u plus 8 square is 4 over 2, 32a. So now we can take 8 common there by dividing it on both sides by 8. So 81 is equal to u plus 4a. Let's say that is equation number 2. Now we can solve this 1 and 2 simultaneously. So 1 says 25 is equal to u plus 2a, and this says 31 is equal to u plus 4a. Now we subtract equation 2 from 1. So 25 minus 31 is minus 6 is equal to this and this cancelled. 2a minus 4a is minus 2a, or a is equal to 3 meter per second square. And we have to show it in the beginning of this part that show that the speed acceleration of this particle is 3 meters per second square. And we are also asking the speed at the point A, which is the u there. So we can use any one of these equations. So we know that 25 is equal to u plus 2a. 25 as it is, u is unknown, 2 is known to us, 3 is acceleration of that particle. So u is equal to 25 minus 6, that is equal to 90 meter per second. So this is the way that we have solved it for this initial acceleration A there and the initial speed u there at the point A for the first part of this question number 4. Now we are going to solve the next part. The particle P reached D with a speed of 61 meters per second. Find the distance CD. So they are asking at D point, the speed is 61 meters per second, and you are going to calculate this distance C to D for that portion there. Let's say that is part 2 of this exercise. So we know one thing that at the speed V is 61 meters per second. So we are going to calculate the distance in from C to D. So first we are going to calculate the distance. So the speed at the C there, let's say that is U now for this first part of that. But the speed at the C position is unknown. But we know the distance from A to C is basically the initial speed from A to C, let's say it is equal to V. So you know the U which is equal to 90 meters per second. We will calculate here. The distance we know and the acceleration we know. So we can use a distribution from A to C. 2as is equal to V square minus U square. 2 we know, acceleration is 3. The distance between these two is 248 is equal to V square we don't know, but U square is the initial speed at that point, that is equal to 90. So V square is equal to 6 into 248 plus 90 square there. And that value will be equal to 1488 plus 361 1849 and V value will be equal to the square root of this 43 meters per second. This is the speed at the point C here. Now, this will become the initial speed later on. So this V is equal to U now, and that is equal to 43 meters per second. Your final speed going to reach at the point D there with a speed of 61 meters per second. And now we are going to calculate this distance CD. So again we will use the same formula there. 2as is equal to V square minus U square. 2 we know, acceleration is the same, 3 there. Distance is x there. V there is 61 square minus U there is 43 square. So x is equal to 61 square minus 43 square over 6. 312 meter. That is the distance of C to D there. So this is the second part of this question. We have to calculate the distance C to D of this question there. Now we are solving question number 5. A particle of mass 20 kg is on a rough plane inclined at an angle of 60 degrees to the horizontal. Equilibrium is maintained by a force of magnitude P Newton acting on the particle in the direction parallel to the line of the greatest slope of the plane there. The greatest possible values of P is twice the least value of the possible values of P. Find the value of the coefficient of friction between the particle and the plane there. In this question, they are asking that P is acting along this greatest slope, and you are going to find out the value of the coefficient of friction, where the condition given there is the greatest value of P is twice the least value of the possible values of P. So first we are going to get the greatest value there. So we are going to solve it into the components. It is nomination R. This is mg cos of 60, and this one is mg sine of 60. Because we are getting the greatest value, so it means P is going to act in this opposite direction with that value. So, and particle is in equilibrium. So this means we know that driving force minus resistive force is equal to ma, and it is equal to 0 because acceleration is equal to 0. So driving force is here P there, minus the resistive force there is equal to mg sine of alpha plus this frictional force is equal to 0. But we know that the frictional force is equal to mu r, and r is basically equal to mg cos of 60. So frictional force is equal to mu mg cos of 60 there. So we are going to use this into this equation. So P value for the greatest is equal to mg sine of 60 plus mu, and r there is equal to mg cos of 60. So this is equal to m is 20 there, g is 10, sine 60 is equal to 0.866 plus mu asterisk m is 20, g is 10, cos 60 is 0.5. So this value will be equal to 200 173.2 plus 100 mu. That is equation number 1 now. Now, the second case is there that we are going to get the least value of this period. And the same case would be there. This 60 angle there. Particle is at this position. This is the normal reaction R to that. This is mg cos of 60. This is mg sin of 60. And now, here frictional force is in the same direction, but the particle frictional force will be in the opposite direction to that. And this is the P position which is acting along that particle, so that it is still in equilibrium there. Again, R is equal to mg cos of alpha there, and F is equal to mu R. That is the same thing we are going to put. Just the equation change there, but the value of P is going to be changed. So in this part, it is in equilibrium. So driving force is P plus mg sine of 60 minus the frictional force F, and that is equal to ma, and that thing is equal to 0. So P plus mg sine of 60 minus mu R is equal to mg cos of 60, that is equal to 0. So P value for the least is equal to mu mg cos of 60 minus mg sin of 60. Mu is as unknown there, where mg cos of 60 there is equal to hundred mu minus mg sin of 60, that is equal to 173.2. So this is the least value of P here. But the condition given there is that the greatest value of P is twice the least value of this P. So greatest value is equal to 173.2 plus 100 mu is equal to twice of the least value of P, that is 100 mu minus 173.2. So 173.2 plus 100 mu is equal to 200 mu minus 2 into 173.2 there. So 100 mu is equal to 2 into 1.732 plus 173.2. So that thing is equal to 0.05. So this is the coefficient of friction between the two particles when you are going to apply the least force of P and the greatest value of P there. with the condition that the greatest value is twice the least value. Now we are solving the next question, which is question number 6. A particle P moves along a straight line through a point O. At t seconds, the acceleration is a meters per second square of P is given by a is equal to 6 minus 0.4 t. The particle comes to rest at the time t is equal to 20. Find the value of t for which the particle is again at rest. There is part 1. Hence, acceleration is equal to 6 minus 0.24 t. We know that if we integrate acceleration with respect to time, you get the velocity there. So, velocity is equal to acceleration is 6 minus 0.42 t dt. This will become v is equal to 6t minus 0.4 t t square over 2 plus the constant of integration. Or v is equal to 6t minus 0.12 t square plus constant of integration a. But the velocity is 20 when v is equal to 0. So v is equal to 0, t is 20 plus c. So c value will be equal to 0.12 into 20 square is 400 minus 6 into 20, that is 120. So c value is equal to minus 72. So the velocity v will be given equal to 6t minus 0.12 t square minus 0.72. This is the velocity v here. And when it comes to the rest, they have asked, then when it comes to the rest, so that means what? Velocity is equal to 0. Then 6t minus 0.12 t square minus 0.72 t is equal to 0. 6 we can take common there. T minus 0.02 t square minus point is equal to 0. Or we can write this thing as 0.02 t square minus point t plus 0.12 is equal to 0. Or t square minus 1 over 0.02 t plus 0.12 over 0.02 is equal to 0. Or t square minus 50t plus 6 equal to So we can make it t square minus 6 over 0.12 t plus 72 over 0.12 is equal to 0. So t square minus 50t plus 600 equal to 0. Now you can use the factors method for t square minus 50t plus 600. So 20 to 30, that t square minus 20t minus 30t plus 600 is equal to 0. T is common. T minus 20 minus 30 is common. T minus 20 equal to 0, or T minus 20 into T minus 30, that is equal to 0. So T is equal to 20 and 30. But 20 seconds already there. So T is equal to 30 seconds when it will be at rest again. For this expression, A is equal to 6 minus 0.42 T. Second part, find the distance traveled between the time of this instantaneously rest pair. On the second part, they are asking the distance between these two timings. That means what S30 minus S20 is going to be calculated for this part here. So the distance between these two timings is S is basically equal to the integration of velocity time for that part from the 20 to 30. So this will become 20 to 30. The acceleration there is 6t minus velocity, that is 6t minus 0.12 t square minus 72 into dt. So that will be equal to 6t square over 2 minus 0.12 t cube over 3 minus 72t plus constant of integration v there for this distance s. But we know one thing, that it is 20 to 30. So this will become s is equal to 3t square minus 0.04 t cube minus 72t from 20 to 30. So put t is equal to 30 first, minus t is equal to 20, and that value is equal to minus 540 minus 560. So this thing will equal to minus minus plus. So 560 minus 540, that is equal to 20 meters. Is the distance between these two timings when it is at rest at 20 and then again it is at rest at 30. So this distance between these two timings is equal to 20 meter there. Now question number. Now we are starting question number 7. As shown in the diagram, a particle A of mass 1.6 kg lies on the horizontal plane and a particle B of mass 2.4 kg lies on the plane inclined an angle of 30 degree to the horizontal. The particles are connected by a light inextensible string which passes over a smooth pulley P fixed at the top of this inclined plane. The distance AP is 2.5 meters and the distance of B from the bottom of the inclined plane is 1 meter. There is a barrier at the bottom of the inclined plane preventing any further motion of B. The part BP of the string is parallel to the line of the greatest slope of the inclined plane. The particles are released from rest with both parts of the string taut. Given that the both planes are smooth, find the acceleration A and the tension in the string. Since both the particles are shown as it is given in the diagram, particle A is at this position, which is passing over this point P there, and that is an inclined plane shown at this point there, where the particle B is there. The particle A has the mass 1.6 kg and the particle B has the mass as 2.4 kg. It is making an angle of 20 degree with the horizontal. This A to the B distance given there is 2.5 meters and B particle is above this plane is having a height of 1 meter. Both planes are smooth. It means for the first part, the frictional force is equal to 0 there. And we are finding the acceleration A and the tension in the string there, T. So let's say this is the tension T in this direction and this is the tension T in this direction because they are opposite in the direction and equal in their magnitudes. A will have this R. This is the weight of A. This is the frictional force which is 0 there. And for this P particle, we are going to resolve this part. This will be the normal reaction R. This is mass of B into G into cos of 30. And this is mass of B into G into sine of 30 there. Because it has smooth surface, so its frictional force is also equal to 0 there. Now we are going to solve it for this particle A. The motion is horizontal there. So tension is driving force minus resistive force is equal to net force. Driving force for this particle is T there, minus resistive force is F there, is equal to mass of that particle is 1.6 into acceleration A. So T minus 0 is equal to 1.6 A, or T is equal to 1.6 A. Let's say it is equation number 1. Now for this particle B there, the driving force is mg, mass of B into G into sine of 30 minus tension minus friction is equal to mass of B into A. So m of B into G into sine of 30 minus tension minus 0 is equal to mass of B into A. Now we put the values into this. Mass of B is 2.4 into G is 10 into sine of 30 minus tension is equal to 2.4a. That is equation number 2. If we further solve it, this 24 sine 30 is half minus t is equal to 2.4a, or 12 minus t is equal to 2.4a. Let's say that is equation number 2 here. Now we can solve this 1 and 2 simultaneously. Tension is equal to 1.6a, it is equation number 1. And for this, it is 12 minus t is equal to 2.4a. Now, if we add these two, this is plus t and minus t cancel. So 12 is equal to 4a, or a is equal to 3 meters per second square. That is the acceleration of this particle A or particle B. They are moving this distance there. Now, the other part is there. You are going to find out the tension in that string. So T is equal to 1.6 into A. 1.6 acceleration is A, there is 3. So that is equal to 4.8 into. So that is the tension of that string in this case there. So this is the solution of this part 1, where you are going to find out the acceleration and the tension in that string there. Now for the second part, it is given that the horizontal plane is rough and the coefficient of friction between the plane A and the horizontal plane is 0.2. The inclined plane is smooth. Find the total distance traveled by this particle A. Now, for the second part, the coefficient of friction between the particle A and the plane is 0.2, and the B surface is still smooth there. Now you have to find out the total distance traveled by this particle A. So this is the case now. It is 30-degree angle at this point. Here is point A. This is the tension in that string, and that is 1 meter above this. Now it is having friction force there, but this having no friction force in the second part, so it is equal to 0. We solve this into two parts. R This is N B G cos of 30, and this is N B G sine of 30 here. So first we are going to find out the acceleration of these two, and then with the help of the acceleration, it has covered 1 meter, and then it will stop there. We will find it one by one in the situation there. So first we are going to find out the acceleration in that particle there. So in the first part, for A, tension minus friction is equal to ma. Tension is as it is there. Frictional force is mu r is equal to ma. Tension is equal to mu. R is the weight of A is equal to m of A there. Our tension is equal to mu m of A into G plus m of A into the acceleration A there. Now we put the values into this, and after this we are going to get these values, because for 1 meter it is having this frictional force there. So tension is as this, mu is 0.2, mass of A is 1.6, G is 10, plus mass of A is 1.6 into the acceleration A there. So that is going to be tension is equal to 3.2 plus 1.6A. Let's say it is equation number 1. For this particle B there, the frictional force is 0 there. The driving force is M of B G sine of 30 minus tension is equal to mass of that particle is 2.4 into A there. So M is 2.4 into 10 into sine 30 is half, minus T is equal to 2.48 24 over 2, that is 12, minus T is equal to 2.48 there. So we will solve the next part now on this side. So solving this 1 and 2. So 1 says that T minus 3.2 is equal to 1.6A, and 2 says 12 minus T is equal to 2.48. Now we add these two, which is T and minus T cancel out. 12 minus 3 is 9. That is equal to 4A. Or A is equal to 9 over 4. So A value is equal to 8.8 over 4. That is equal to 2.2 meters per second square. So the motion of this particle A, starting from this, where u is equal to 0, it is going to A dash with an acceleration of 2.2 meter per second, and we want to get the velocity of this v, where it has to cover 1 meter, because v is 1 meter above this point there, where it is making an angle of 30 degree to that. So first this will be calculated, then from A to A double dash. Now frictional force is there, but the driving force in this part is equal to 0. So we will find out this frictional force there, and then we will calculate this distance from A dash to A double dash. Let's say that is equal to x there, and this is 1 meter there. Total distance traveled by A particle is 1 plus x. So you are going to find out the value of x for this portion there. Now we say that it is V is, we know that distance is 1 meter, U is 0 there, acceleration is 2.2. So V square minus U square is equal to 2as for this first part of A dash there. So V square is unknown, U square is 0, 2 we know, A value is there 2.2, into S is 1 there. So this means V square is equal to 4.4. So this is V square. Again, for the next part, this V will become U there, so it will become U square there. Now, for this V, it is now coming U, and at this point, it is going to stop there before V is going to touch the ground and string is slack there. Now here, from A dash to A double dash, there is no driving force because tension is equal to 0. Only one force acting there, that is the frictional force. So we know that driving force minus resistive force is equal to MA. Driving force is 0 there, minus resistive force is mu R is equal to MA minus mu. R is equal to mass of A into G is equal to mass of A into A. Mass of A and mass of A is cancelled out. So A is equal to A dash, we can write it now. A dash is equal to minus mu G. Mu is there minus 0.2 into G there is 10. So that value is equal to minus 2 meter per second square. This is the new acceleration from A dash to A double dash there. Now you know this acceleration there, and you are going to find out velocity is U square, which is 4.4, and now you can calculate that value there. A dash S is equal to V square minus U square. 2 we know that A dash is equal to minus 2. S is X there. V square is equal to 0 square minus U square is 4.4, which we have already calculated to that part there. Because the final velocity for A dash is the initial velocity for A dash for the distance of A double dash to that part there. So this will become minus 4x is equal to minus 4.4. This and this is going to cancel. So x is equal to 4.4 over 4. That is equal to 1.1 meter there. So the total distance traveled by A there is, in the equation if you put into this third, then it is 1 plus x. So 1x is, and x we have calculated as 1.1. So this is equal to 2.1 meter. That is the distance total traveled by this particle A before it comes to the rest at that position there. So this is the final solution of this problem number 7 in this question there. So that is the end of this paper 7, paper 2018, Mechanics 9709/42.